All right. How's everybody today? Doing good? Good, good. Okay, so we're pretty much wrapped up with our first lesson on probability. This is where we left off yesterday. We were talking about this problem where you've got three boxes full of white balls and black balls, and you're taking one from each, putting it in the next, and ultimately you're wanting to end up, what's the probability of choosing a white ball? What's the probability that the last ball you choose is black? Okay, so we'll get to that in just a second. Don't forget that the next couple of days, Friday is the end of the 6 weeks. So if there's anything outstanding you need to take care of, if there's still a homework assignment, or if you wanted to retake the past exam, anything like that, tomorrow morning at 8:05 is when that deadline will be. Okay, did anybody go home and get the answer?
I have an answer.
You have an answer? Okay. Eli, what'd you get?
I simplified. I got like 52/75 for black, or for white, actually.
Now, I will agree with the 75ths,
Okay, so I got that part right.
but not on the numerator. Spencer, what'd you get? There you go. 38 out of 75 for white, 37 out of 75 for the black ball. Okay, now let's kind of walk through how we got this. So the problem says there are three boxes on a table. The first box contains three white balls and two black. The second contains one white and one black. And the third contains two white and two black balls. Without looking, if you take one ball from the first box, put it in the second. Then you take a ball from the second, put it in the third. Finally, you choose a ball from the third box, all without looking. What's the probability that the last ball you choose is white? Okay, so let's start here. Now I'm going to have to kind of go up and down to make sure this works, but we're going to go ahead and branch it off. Now there's only two branches the first time around because I only have two choices, right? I'm either going to choose a white ball or a black ball. Remember, all of this is without looking. So what's the probability of my choosing a white ball? 3 out of 5, right? So 3/5. And there would be a probability of 2/5 for choosing a black ball. Now, we have to go ahead and work with the second box. We already know it has one white and one black. So if I chose the white ball, well then in this second box I would have two white and one black. Does that make sense? If I'd chosen a black ball, the second box would now have what? Okay. White, two black. All right. Is everybody okay with what I'm doing? Okay, well, now we're going to go ahead and choose a ball from each of these. So again, without looking, let's say I choose a white ball. Okay, what are the odds of that for the second box now? 2/3. So there's two white out of the three total. Okay, what if I choose a black ball? Okay, 1/3. And then down here, had I originally chosen a black ball, then the white ball would be 1/3 and the black would be 2/3. And you remember, as you start to branch out on these diagrams, one of the things I mentioned yesterday is that these joining branches, they should add up to what? Yeah, the 100%. Remember, every possible outcome. So see, we have 3/5 and 2/5, which is 5/5, that's 1. Same thing on these branches here, 2/3 and 1/3 is 3/3, so that's 1 as well. Okay, so now waiting in the third box is two white and two black. All right, so this one represents the white, the black. This one represents the white and the black. Okay, so now for each of these, I'm going to have a box. Okay, so there was two white and two black, correct? So if I'd chosen a white ball, then there would now be three white and two black. If I'd chosen the black ball, then there would be, okay. Oh, okay. And then we go down here. Had I chosen the white ball, then I would have three white, two black. Had I chosen the black ball, then I would have three black and two white. Now we're on the final choice. Okay, but instead of breaking these up into two more, I'm just going to go ahead and focus on the one color because I'm going to show you something that I did with this. Let's just go ahead and say I'm going to choose a white ball now. Okay, so what I have here, what's the probability of getting a white ball? 3/5. So this would be 3/5. Okay, that's a white ball. Then this one would be 2/5. That's white. Then 3/5 for the white and 2/5. Okay, for the white. All right. Now, you remember one of the things we did talk about yesterday, and it was kind of letting you know what's coming up. If you followed each of these branches along, that was an intersection. Okay, that was equivalent to an intersection, what we were talking about. The union comes from the probability at the end of those branches. So let's say the probability of choosing white every time. What would that be? See, the first probability for a white was 3/5, then 2/3, and then what is it? That's exactly right. You just multiply the probabilities along that particular branch. So this one has a probability of 18 out of 75 of getting a white ball. Okay, but now you're focused. Remember on this one, the end result, I'm only focused on the white ball now. I'm going to deal with the black ball in just a second. So now let's follow the second branch. So this time I'm going to take 3/5 times what? 1/3 times 2/5. So that would be 6/75. Okay. Now, if I had originally chosen a black ball, but see, I'm still ending up with a white ball. So 2/5 times 1/3 times 3/5. Another 6/75. And the final one, if I'd chosen black the first two times, but then ultimately chose white. 2/5 times 2/3 times 2/5. 12? 8. There we go. 8/75. 8/75. Okay. So see, ultimately, we want to know what's the probability out of all these outcomes of doing this particular scenario and then ending up with a white ball. Well, the intersections are each of these four branches. Well, this is 4 different ways you can end up with a white ball. The union is to now take the sum of all those possible outcomes. Okay. So if the probability of choosing all white balls the 3 times, 18 out of 75. Okay, choosing one white, then black, then white, 6 out of 75. And remember, what did Spencer say his answer was? The probability of white was the 38 out of 75. Well, help me out. 18 plus 6 plus 6 plus 8. There you go. So the probability of choosing a white ball, or ending up with a white ball, I should say, at the end, is 38 out of 75. Now, could I have easily done the same thing, shown the other branches at the very end for the black as well? Followed along those, but there's something I can do that'll save me a little bit of work. Well, there's only 2 outcomes here, right? The probability of choosing black would also be the same as what? Of getting not white. So basically, we're looking for its complement, right? So 100%, we're dealing with this. Okay, let me go ahead and write this out. So the probability of ending up with a black ball, okay, well, is just the same as the probability of not getting a white ball. And we know what the probability of getting a white ball is. So I'm going to take 100%, and subtract the probability that we have. So the common denominator would be 75/75. That's 1. Minus 38/75. Okay. So what's the probability of choosing or getting a black ball at the end? 37/75. There you go. And see, that's the thing about probability. It always seems like the problems are much larger and more complicated than you think, but when you really just try to visualize it in the lattice diagram or a tree diagram, it really helps you understand to see what's going on. Did anybody else get that right? Okay. That'd be good. Good. Did anybody get close? Anybody get the tree diagram?
I got the tree diagram.
Okay.
They messed up on it. So I'm saying 8/75. I said 12/75.
Oh, that's where you messed up. Okay.
I did the black.
Okay. All right, good, 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 good. Well, let me go ahead. Now that we're done with that first lesson, here's your assignment. So I'm going to go ahead and give you the rest of the time to go ahead and look over this. In fact, if you want, we could even go ahead and work one of these together. The rest of my family is DC. My son this year, he's actually not a superhero. He wanted to be a shadow demon. So he's one of those black suits that completely covers your entire body. And it's got eyes that kind of glow in and out red. So it's pretty cool. Now, my daughter, she's Wonder Woman. So it's awesome. I don't know what my wife is going to be. She was, this past weekend, when we went out to some of the trunk or treat events on Saturday and Sunday, she dressed up as Harley Quinn. But I don't think she was going to do that tonight. She likes to change costumes, so I like to be the Joker. I got to be me. Yeah. Now, I will say this past weekend I was the Riddler. I have an actual suit with question marks all over it. It's bright green. It's really cool looking. And what amazed me was that at some of the trunk or treat events, some people walked up, "Who are you?" And I was like, "Well, I'm the Riddler." "Who's that?" I was like, "Okay." Like, it's a Batman villain. Hey, Louis. On usually when Fridays are Friday the 13th, I like to stand here with my hockey mask. Yeah, kind of scare people too. I don't know if a Friday this year falls on a Friday the 13th. If it does, you're warned. Peyton? I think Peyton had the best reaction for this class. I had in fifth period someone, you have that because when you get scared, you have what's coined the fight or flight response. And this girl just went, huh! She immediately got into stance. I mean, she was ready to go. I was like, oh. Are you talking about when the guy walks into the kitchen and he goes, huh? Yeah, I know which one you're talking about. That's pretty funny. And I will say, I've been doing this for a lot of years. There's only been one time where a student has actually punched me. And it hasn't been in the face, but, I can't blame the student for that, because if you're going to put yourself in a position where you're going to scare somebody, you can't, blame them for how they react. But does anybody in here know James Latour? Yes. He came in, it was last year, and I scared the crap out of him. He just, he did a double fist punch to my chest. I mean, he reacted. He was, ooh. So he took care of it. I had to get up about a half hour earlier than I normally do.
Really? Just a half hour?
It's not a whole lot. It's not bad. All right, well, let's take a look. Is it hard to get? Oh, not really. It just takes a little bit of scrubbing. The kind of makeup we use isn't horrible to get off, not like some we used to have, especially with the black paint. I would be scrubbing my eyeballs and it just would not come off. So the next day I'd look like I got in a fight. But hopefully tomorrow that's not the case. We'll see. Somebody put what?
I accidentally put latex on my hair when putting these on, so if I have a bald spot up here, you know what?
There you go.
Yeah.
There you go. Yeah. Hair will grow back at a certain point. Not for me anymore. I've forgotten what it's like to have hair. All right. I know, right? There you go. Okay, so is there a particular problem on the assignment you would like to look at? If it wasn't number 5, probably the one that, and again, I want to say it was the toughest. It was just the one that I needed to be the most careful on, was number 6 with the lattice diagram. But that's just me. You want to do number 5? Okay, we could do that.
Are we gonna do more than one
We
square?
just do it on your paper.
No, we'll just do one. Now, if you want to, I can leave this up and people can come up and you can work it as a class if you want to. I'd be okay with that. So which one do we want to work together with me?
Number
4 or 5? Okay. How many people want number 4? How many people want number 5? Okay. Well, more hands went up, so we will take a look at number 5. We're talking about a dartboard here. Okay. Now, a dartboard has 26 sectors labeled 1 to 36. Determine the probability that a dart thrown at the center of the board will hit a multiple of 4. Okay.
36.
I'm sorry?
Ours says it has 36 sectors. Only 26.
That's weird.
No, I just can't.
Oh, no. No, we're good. What's the probability that you'll enjoy this problem? 10 out of 10. Thank you, John. Thank you, John. All right. Well, what I will do, I kind of just marked the numbers as I went around very lightly with a pencil, and then when I went on to the next part of the problem, I went ahead and erased it. Like, for example, I'm looking for any multiple of 4. So 4, 8, 12, 16, 20, 24, 28, 32, and 36. And how many did I circle?
9.
There you go. So what's the probability that the dart's going to hit a multiple of 4? Well, there are 9 possibilities out of the 36 total. So I'd say that's a 1 in 4 chance of it happening. Okay. So we don't want to do number 5?
No. Let's do.
I could do part of one and part of the other. Okay. You want me to go to 4A? Okay. Illustrate on a tree diagram the sample space for simultaneously tossing a 5-cent and a 10-cent coin. Okay. Well, how many total outcomes do you think there would be? Well, now if you toss both coins, there would be 4 total. So it really doesn't matter which one you go ahead and put first. Okay. For the 5-cent coin, you've only got 2 possible outcomes. It's either heads or tails. But then the other toss, the one representing the 10-cent coin, again, it only has 2 choices for each. Head, tails, head, tails. So what are all the possible combinations? See, here's the 4. We can either get 2 heads, 2 tails, or 1 of each. So that's all you're wanting to do on that number 4. A, B, C, D is just draw a diagram to illustrate every outcome. Okay. Do you want to try one of the problems in 6 since we're kind of skipping around?
Yes.
Which one?
All of it.
All of it. A, B, C, D, E, F. You know, what's hard for one person may be really easy for another. Well,
Okay, I have a question.
okay.
So on 6C, it says a 5 or a 6. So does that mean like as long as like on one of the die we roll
As long as one of them is a 5.
all the options are 5 and 6. So
Okay, so let's take a look at that real quick. Okay, use the grid. This is my lattice diagram to determine the probability of getting a 5 or a 6. Yeah, and these key words are going to be real important. Okay. So the or, remember, that's the union. That's our marriage, the combination. So what am I looking at here? How many favorable outcomes do I have? We already know that there's 36 total outcomes. Okay. Now where are we getting the 20 from?
so we've got on die 2 we have both the rows for 5 and 6. Right?
Uh-huh.
And then for die 1 we have the two columns for 5 and 6, but 4 of those are part of the 2 rows of 5 and 6.
Okay. So basically, you're talking about. Let me do this in red so everybody can see it. That's a red there. It says a 5 or a 6, right? So one die could land a 5 or a 6. The second die could land a 5 or a 6, and there's 20 options there. Yeah. So 20 out of 36 would be. Okay. There you go. That's exactly right. Now, will 5 or a 6 be different from 5 and a 6? Okay. In fact, let's go ahead and take a look at that one. What does and mean? Okay. So this one right here was 5 knights. Okay, so the and, remember that's my intersection. Okay, what they both have. So we can't just take anything with a 5 or a 6. It has to be specific. So if one die, let me go ahead and erase this. If one die lands on a 5, the other one would have to land on a 6. Or if the first die lands on a 6, then the other one would have to land on a 5. So there's only 2 ways out of the 36 that we can get a 5 and a 6. And what would that be? 1/18. There you go. Making sense? Well, hi. All right. Well, good. I'm going to go ahead and turn you guys loose. Do you want me to leave this up? Is someone willing to come up here and kind of be the moderator while you guys work together, or you just want to work?
What do you mean moderator?
Like what I do. Like if someone wants to kind of lead the problems.
If I come up there, can I choose to do it and then write it?
If people would love to come up, yeah.
But don't take me.
The what?
What's up there? So
Do you want the
the
yeah.
random? That's it. Yes, my random.
Does anybody else
36. Oh my gosh. I just pressed a button. Did I turn it off?
Oh, I think it did shut down. Wait a minute, where's
No, it's all the way to the right.
where's it going? I think
There it is.
no, it's still going.
Then what was the thingy? Okay, whatever. It's fine. We're
I
fine.
don't know, that was weird.
Now we can go to 4.
25 over 36. Yay, go Gabby. Okay. Now we're going to work on number 4. Illustrate on a tree diagram the sample space for number
It's actually really easy, guys.
letter A, simultaneously tossing a 5-cent and a 10-cent coin.
And remember, A, we already got this out.
Oh. Just kidding. We're going to work on B. Tossing a coin and twirling an equilateral triangular spinner, labeling A, B, and C. A spinner, that's a triangle. Wait, actually? Is that it? Did I get that right?
Yeah, it has 3 sides, A, B, and C. Yeah. No, you don't have to draw. You don't.
Yes. Wait, so that's, okay, we'll just do that. So, we have a coin. I don't know if I'm, A, B, and C.
Why are you drawing A?
Because those are the options that we have.
Okay, so shouldn't it be A, B, and C, and then you toss the coin to like?
Yeah.
Yes,
Well-
there's actually really 2 ways you could draw it.
Yeah.
You could either start with the coin or start with the spinner.
And do we just like do A, T, A?
Yeah, because think about it, there's 2 outcomes for the coin. How many outcomes for the spinner? 3, so you should have a total of 6 possible outcomes.
Oh,
Just right off the like,
so then,
Could, but following the branches on your tree diagram gives you all of those outcomes.
on the ABC like triangular thingy, do we also put H and T?
Yeah, you could do that, yeah.
But then, oh, I guess that is right.
Mm-hmm.
And we don't need to do anything else.
And now you'll go ahead and start it over here because on the first spin, you can get either an A, B, or C, right?
Yes, but what do you
The tree
mean?
has to originate somewhere.
Yeah, so,
So from some point, yeah, there you go. There you go.
Oh.
like that?
Yeah.
Oh, for 8, which
Yay!
Yes, let's start tomorrow. No, we're gonna go ahead and make this due Monday.
Okay,
So there's plenty of time.
cool.
All the comments in a problem. Can I come with
Yes, please take the headphones.
Can I play teacher now? I won't call anybody else a woman, I promise.
You're gonna lose your job.
Hey, absent people. You're missing a great class. I'm going to do all of 4. Is there the circle function?
Oh, sometimes it doesn't work. Try it.
I think you can only do
There you go.
There we go. Sweet. Do we have extra space?
We do. You can scroll.
Sweet. Yeah. So we're on. So what are we explaining now? Which one? Are we doing 4B now?
No, we already did it. We're doing 4C.
So is everybody good on 4B?
Yes.
Okay, so let's do 4C now. Sweet. Right, so 4C, so we have 2 spinners this time, not just 1. Both of them have 3 sides, right? So the first one. Sweet. So the first one, you have 3 sides. 1, 2, 3, right? And then we spin the second one right after. That's X, Y, Z, right? So this one, we have 3 options after. Right? So spin the first spinner once. 3 options of what can happen. 1, 2, 3. Then we spin the second one, and after that first option, we have 3 options after that. X, Y, Z.
That's it.
Good? Perfect.
So you have 9 separate branches.
Yeah. Okay. 4D now? D? Yeah. We're gonna do that now. Come on, smartboard. I'm a jerk sometimes. Dude, that's not my only problem. Sweet. So we have 2 tickets, and then a number of pink, blue, and white tickets. So, ticket 1, ticket 2, and then after that we have 3 options. Pink, blue, white, pink, blue, white. Yeah, it's the same as the last one.
Very close.
No.
You could still be over here.
Like if you're drawing 2 tickets, you're drawing a pink, blue, and a white, and then a pink, blue, and a white also.
Oh! You right, my B.
So do we just add another?
It's weird, it only took half of them.
Okay, sweet. So,
There you go. Because look at that first set of branches is the first draw, and then the next group would be the second draw.
who? Yeah. Sure. Sweet. Are we all good? How much time do we have left? We got 4 minutes. We have 4 minutes.
So we have a little over probably 3 minutes left. Just go ahead and stop. Okay. All righty. Good job, guys. Good job.